Howdy, everybody. All right, we're moving on to 10.5. We're skipping over 10.4 for right now. We're going to work on 10.5, tangent lines. This video might be a little bit longer because there's a lot of material, so don't be afraid to stop, catch up, stop, catch up, stop, catch up. Okie dokie? All right, so here we go. Objective, to use the properties of a tangent to a circle. Why is the angle formed at a point of tangency important? That's what we're going to find out. So a tangent to a circle is a line in the plane of the circle that intersects the circle in exactly one point. So that means it only touches the circle at exactly one point. So it does not go through the circle, it lays up against the circle. The point where the circle and the tangent intersect is called the point of tangency. So this is the point of tangency, and it just butts up against that circle. Doesn't go in it, just barely touches it. Ray BA is a tangent ray, which would be on and on and on and on and on and on forever, versus a tangent segment, which is just the piece, which has an ending point. So you can have a line tangent to a circle, or you can have a segment tangent to a circle. Okay, so that's a tangent line. And here's your first theorem. If a line is tangent to a circle, if you have a line that is tangent to a circle, then the line is perpendicular to the radius at the point of tangency. So if the line is tangent, then the line is perpendicular. Perpendicular to what? Perpendicular to the radius. Where is it perpendicular at? At the point of tangency. All right, so if line AB is tangent to circle O, then line AB is perpendicular to the radius, which is OP. Let me change this light around a little bit. It seems to be really throwing off a shadow. See if that's any better. Okay. So this is really important because perpendicular means there's a right angle here. Okay, and then we need to think. Perpendicular equals 90. And then, as always, we could always add in an extra line, and then we begin to think right triangles. So everything we've learned is going to be incorporated in circles, triangles, tangents, radiuses, etc. Okay, so here we go. Line segment LM, LM, and MN, MN are tangents. They're both tangents to the circle. What is the value of X? Well, something that we learned earlier is that a quadrilateral has 360 degrees. There's 360 degrees in a quadrilateral. Then we can simply add up all the angles. 117 plus X plus, we know because of the word tangent, we know 90 degrees here And because M and N are tangent, we have 90 degrees here. So we have 90 plus 90. And we know because it's a quadrilateral, there's 360 degrees. Okay, so putting it all together, we end up with 297 plus x equals 360. Subtracting 297 from each side. And we simply get that x equals 63 degrees. Okie dokie. All right, moving right along. This is page 1. There's going to be 4 pages today. I've spaced them out very large so you have plenty of room to write. Okay, DE, segment D to E, is tangent. Right away, we think of that word tangent, and we know that that should mean 90 degrees. If DE is tangent to the circle, what is the value of x? Well, x is out here. This happens to be inside of a triangle. How many degrees are in a triangle? Yep, 180. So we end up with 90 degrees because it's tangent, plus 38 degrees, plus this angle x has got to equal 180. Putting these two together, we end up with 90 and 38 is 128 degrees, plus x equals 180. Subtract 128 from both sides, and we get x is simply 52 degrees. Not so bad. Here we're using the properties of a triangle. Okay, next theorem. If a line in the plane of a circle is perpendicular, what does perpendicular mean? Makes 90 degrees. If it's perpendicular to the radius, if the line is perpendicular, makes a right angle to the radius, then the line is tangent to the circle. So this would be a converse. Before, it was 90 degrees, it was tangent, therefore it was 90. Now we're going to have, it's a line and it's 90 degrees, therefore it must be tangent. So we end up with a converse here, going the other direction. If the line is perpendicular, 90 degrees, if the line is perpendicular 90 degrees to the circle, then OP must be the radius. If it's tangent and it's perpendicular, then it must be the radius that it's perpendicular to. What is the radius of circle O? Okay, we have a right triangle, and then we don't want to forget the things that we know. It's a right triangle. Therefore, we can simply use a squared plus b squared equals c squared. We could always use trig. Don't forget those kind of things. Okay, where x, we're going to let that be equal to a. We're going to let 10 be equal to b. And my dog, the hypotenuse, is going to be c. But is it just 6 that is c? No, that's only part of it. We have this piece over here. So it's really segment addition. X plus 6 equals c. So I'm going to write this like this. So you can see that x plus 6 is really the distance of C. Segment addition here. Let's make sure you remember to put these pieces together if necessary. Okay? Then it's just Pythagorean theorem. We end up with x squared a plus 10 squared equals x plus 6 squared. And don't forget, this is x plus 6 squared, which is simply x plus 6 times x plus 6. We know that 10 squared is simply 100, and x squared is x squared. All right, remember that when these are done, you can do it by two methods, foiling or box method. And I'm going to go ahead and do the box method just so we can kind of review. We have a box. It's a 2 by 2, so we're going to have 2 times 2, 4 boxes. We put the numbers on the outside, x plus 6, x plus 6, and then we multiply. X times x is x squared. X times 6 is 6x. X times 6 is 6x. And 6 times 6 is positive 36. And then we simply put it all together. So we have x squared plus 100 equals x squared. 6x plus 6x is 12x plus 36. And the really cool thing about this is when we subtract x from each side, we end up with them canceling out. We get 100 equals 12x plus 36. Subtract 36 from each side, and we end up with 12x equals, let's see if I can get it right this time, 64. 64 divided by 12, we end up with x equals 4. And we're done. Okay? Page number 3. Okay. This one's a little different, but it's the same thing. The question is segment LM tangent? Is it 90 degrees? Is it perpendicular to the circle N at L? Is this perpendicular? Well, if it is perpendicular, if it is tangent, then this would be 90 degrees. And then we could use Pythagorean's theorem. But we don't know. So the question is it tangent? Well, if it's tangent to LN, which is the radius, then this will be a right triangle. We don't know if it is, so I want to circle this. This is the question. Is it perpendicular? Well, then we do Pythagorean's theorem. All right? This is 7, so we're going to let 7 equal a. So we have a squared plus b squared equals c squared. We're going to let a equal 7, b equals 24. And my dog, remember, my dog is not this piece, it's the whole piece. But what is this piece? We don't have x this time. But don't forget, the radius is always congruent on both sides of the circle. So if this is 7, then this is 7. And then my c is segment addition, 25 plus 7, where c, my dog, remember the hypotenuse is always opposite of where the right angle would be, c would be equal to 32. All right, so a is 7 squared plus b, which is 24 squared. Remember, the question is it equal to 32 squared? So let's find out. 7 squared is 49. 24 squared is, that's a big number. Let's see. 24 times 24 is 576. Let me double check that because I don't want to be doing it wrong. And then you guys will be really mad at me if I make a mistake. So 24 times 24 equals 576. And then 32 squared is 1024. Remember, the question is, are they equal? Put these two together. 576 plus 49 is 625. And this is 1024. Are they equal? Absolutely not. Therefore, segment LM is not perpendicular. It's not perpendicular to line LN, so it is not tangent to the circle. Okay, let me emphasize, we're always checking whether or not these are going to be equal. And in this case, we found out it is not perpendicular. It does not form a right angle, so therefore it's not tangent. Because when you hear the word tangent, you need to start thinking 90 degrees perpendicular. Touches the circle at exactly 1 point. And it's only perpendicular 90 degrees when it intersects with the radius. Okay? So the next theorem is, if two segments touch the circle at exactly 1 point and they share a common endpoint. If these two segments are tangent, they touch the circle at exactly A and C, and they share this common endpoint on the outside of the circle, then the two segments are, you got it, congruent. Okay? So let's shorten it up a little bit. If AB and segment BC are tangent and share a point, in this case it's B, if they are tangent and they share a common endpoint outside the circle, then segment AB is going to be congruent to BC. And we did this earlier when we were talking about circumcenters and orthocenters and stuff like that. We found out that these lines outside ended up being congruent. Sometimes they were inside where they touched the circle at 90 degrees. And then we found out that those were congruent. So applying this sounds like a lot, but it's really, this is the easy part. Okay, so here we go. Let's start with the pink. This is touching the circle at this point, and this point touches the circle, so these two are congruent. So if this is 3M, then this piece would be 3M. And then we have 17. This tangent comes out to this end point, and this tangent comes out to this end point. So if this is 17 meters, then this is 17 meters. And then we go to the next point. From this point, we have this line that's tangent and this line that is tangent. So we end up with, if this is 8 meters, follow it around. This is 8 meters. And last but not least, we've got from this point outside the circle, this point outside the circle to the circle, these two tangents would be congruent. And the question says, what is the perimeter? Well, easy peasy lemon squeezy. We end up with 2 that are 3 meters long, plus 2 that are 17 meters long, plus 2 that are 8 meters long, plus 2 that are 7 meters long, which is going to total 2 times 3 is 6 meters, plus 2 times 17 is 34 meters, plus 2 times 8 is 16 meters, plus 2 times 7, which is 14 meters. And if we put all of these together, we simply get